Hello and welcome to Science Never Stops. I'm your host Joseph Vick with the U.S. Space and Rocket Center. And today's topic is parallel lines and parallelograms. Now, first off, a parallel line are two lines that are of set distance apart from one another. That they stay at that set distance apart, forever traveling in that distance. They never intersect or cross one another in their continuing path. Now, with this parallelogram, with that continuing line movement, you can form shapes with two equal sides with parallel lines. And those shapes we call parallelograms. Now, with the parallel lines first, with the straws that I showed you, notice the lines here. There is this space of distance that will remain the same for their length going in all directions at continuous infinity lengths as the lines travel over time, but when they travel, they will never cross one another. That is a parallel line. Now, when you form parallel lines into shapes, you get a parallelogram. Now, a parallelogram is what you call a quadrilateral polygon, and a quadrilateral is a shape with four sides. Quad, four, lateral, line, four lines, and a polygon is a lined shape, so a shape with lines. So we have a four-sided shape formed with parallel lines. A parallelogram, quadrilateral polygon. Now, to be a parallelogram, it has to have equal, opposite, parallel sides and equal, opposite angles. So this is a picture of a parallelogram on the bottom. The lines denote the equality of what each side or angle is. The single dash shows this side is equal to this side, whereas the double dash shows this side is equal to this side. Now with the angles, the single curve is equal to the opposite angle on the other side. The double curve angle distinction on this side, this curve is equal to the double curve angle on that side. Equal opposite sides and equal opposite angles is what is a parallelogram. Now you can make your own parallelogram using string and straws. So take your straws and you thread them with your string. Take your string and thread it through the straw until you get a parallelogram. So this, in the shape that I hold it now, is what we call a square. Holding up there with the frame with my face in the middle. So with the square, you have four equal sides and four equal right angles that are 90 degrees. This is a square, and by definition of a polygon, it's a parallelogram. You have two equal opposite sides and two equal opposite angles of 90 degrees, and each one of these sides are equal. So a square is an example of a parallelogram. Now let's say we slightly move our square over and create with our square what we call a diamond or a rhombus. And with this, I'll angle it this way so it's easier for me to. So with this, same will apply. You have equal opposite sides that are also running parallel to one another. and equal opposite angles. These are not 90-degree angles as the square was, but these two angles are equal to one another, and the top and the bottom angles are equal to one another. Same applies when I squish it in a little bit further. Still, equal opposite angles, still parallel, equal opposite sides. Now, angles, if you would like to measure them, are measured with a tool called a protractor. You can actually take your design with the straws and the string and measure out the angles, and you can write down what equal and opposite angles are on your parallelogram tool. Now, this is one where there are 4 sides of equal length. You can also have a parallelogram that looks like a rectangle. So I have one here. Notice this side is equal to this side, but these two are a bit shorter. So this is what you call a rectangle. So with this rectangle, we still have equal opposite angles of 90 degrees and equal opposite parallel lined sides. Now let's say I add a little bit more of an angle to it. So you still have the top and the bottom, which my hands are holding, are equal in length and parallel lines, and to the right and the left sides are equal in side length and parallel to one another. And you have equally angles, equal and opposite angles on each side. And you can continue to make your parallelograms as angular, thin as you would like. Now, to see that in a written out version, I did that with the square, where you can see the 4 equal sides and the 4 corners, and the opposite right angles to one another are equal. A square is a parallelogram. So is a rectangle. You have the upper side equal to the bottom, the right and the left sides equal to one another, and the opposite right angles equal to one another. And then you have a rhombus or a diamond with, again, the 4 equal sides, but not necessarily equal to one another. You have the vertices, or the 4 corners, the 4 angles, and then you have the parallel lines, equal and opposite angles to one another. I encourage you to look around your house and outdoors for parallelograms. See and notice parallel lines in your architecture of your home, in the layout of your home. See what things run parallel. See what things do not. Write those down in your journal and discover things that you may have you've looked at on every day but not know what they are or can describe them. So keep looking, keep your eyes open, keep your brain open for learning, and remember, science never stops.